Hi, I'm Brandon Graisley. I'm a high school math teacher, and we're going to review the primary trig ratios today. So here I have a right angle triangle. It's important that it's a right angle triangle for what we're about to do. Here I have these vertices A, B, and C, and so I can refer to these angles. This is angle A, this is angle B, and this is angle C, which you can see is 90 degrees. The sides opposite each angle are labeled with the lowercase versions. So opposite of A we have little a, opposite B we have little b, and opposite C we have little c. And that one is really important. That is the hypotenuse of the triangle. It's the longest side and it's opposite the largest angle, which is 90. Our first ratio is the sine ratio, and if I look at sine of this angle, A, sine of this angle, this is the opposite side of A, the length of the opposite side. So take the opposite of A, which would be little a, and divide it by the length of the hypotenuse. And so in this case, opposite A we have little a, and the hypotenuse is C. So that's the ratio, A divided by C. If we go over here, I'll write it on this side, sine of B, sine of this angle, is the opposite of B divided by the hypotenuse. The opposite of B, there's B, the side opposite it is this one here, little b, and we divide that by the hypotenuse, which is still C. Okay, that's what the sine ratio is. And so if this value was 7 and this value was 12, then sine of A would be 7 divided by 12. So we'll do a few examples in a minute. The cosine, which we short form as cos, is instead of the opposite of A, we're going to have the adjacent side to A. Adjacent means next to something. Adjacent to A, again divided by the hypotenuse. Adjacent to A, there's A. There are two sides that are sort of next to A, but one of them is the hypotenuse. We want the short side, that's the adjacent side, which is going to be B. And again, the hypotenuse is C. Cosine of B, so there's B. If we measure the cosine of B, we want the side that is adjacent to B, and we divide by the length of the hypotenuse. So these are all lengths. Adjacent to B, there's B, there's the hypotenuse, so the other side here is the adjacent side, that's little a, and we divide by C, the hypotenuse. And check this out, see in a triangle, if you have an angle like this, A, the sine of that angle is the cosine of the other angle, A over C, A over C. And the sine of this angle, B, is the cosine of A. So these ratios work out like that. There's a nice little pattern there. And there's one more that we use a lot, and that is the tangent, which we short form tan. Tan of A doesn't use the hypotenuse, it uses the other two sides. And we write it like this. It is always the opposite of A. Let's use the word of here. Opposite of A divided by the one that is adjacent to A. Okay, so the opposite of A, there's A. Opposite is little a. And adjacent is not C, because that's the hypotenuse. Adjacent is B over here. Tan of A is A over B. And then I'm sure you can see tan of B is the opposite of B divided by the side that is adjacent to B. So here's B. Opposite B is little b. Adjacent to B is little a. Again, it's not C because that's the hypotenuse. You want the short sides for the tangent. Oh, and look, I wrote right down off there. You can't see. B over A. B over A. That's the tangent of B. And so there's a little memory aid that a lot of people use. This one here. Let me put it actually on the screen for you. SOHCAHTOA. Sine is opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And tangent is opposite over adjacent. So sine, cos, and tan, opposite over hypotenuse for sine, adjacent over hypotenuse for cos, opposite over adjacent for tangent. You got to know those. Just memorize it this way if you want to, but you have to understand by looking at any triangle, which sides are opposite and which sides are adjacent. So let's do a quick example using those. We'll do a few here. So we often talk about solving triangles using the ratios. So let's say I have a triangle like this one. Let's see, something like that. And we have A, B, and C. I'll use the same letters for now. Let's say side AC has a length of 8. I'm going to call this little a. This is little c. And I know what one of the angles is, 40 degrees. And the question is to find all of the other pieces of information. What are these two sides? What is this other angle? And so we know everything there is to know about this triangle. Well, the first thing is that triangles, the angles always add up to 180 degrees. So I know that angle B plus 40 degrees plus 90 degrees equals 180 degrees. And so B has to be equal to 50 degrees. So I'll just write that. Maybe I'll use a different color here. I'll just write that on the diagram. That's 50 degrees. So that's nice. We know that. Let's see. We can use a few other things to try to figure out these values. So we know 8. So we want to make sure we include this side in whatever calculation we do. And we know this angle here. Well, what if I use the tangent, tan, of A, tan of 40 degrees? That's going to be the opposite to A, little a, divided by the adjacent side, which is 8. That'll be A over 8. Alright, that's pretty good. I can solve this. That means that 8, I'm going to multiply both sides by 8. 8 times the tan of 40 equals A. And let me just grab a calculator here. If I take 8 times, I press 40 and then the tan button and then equals. That'll do the multiplication. I get 6.712. So about 6.712. Let me just write that on my diagram here. About 6.712. Okay, so now I have A, and I need to get C still. Well, I could still use this 40 degrees and this 8 to get C. I don't really want to use this decimal value that is not perfect. It's an approximation. If possible, I'm going to use just the values I already have. And I can use 8, C, and 40 in a single expression here. Well, I want to use the, if I use 40, I want to use the adjacent side and the hypotenuse. That sounds to me like cosine. So cosine of 40 degrees is the adjacent side to A, which is 8, divided by the hypotenuse of the triangle, which is C. Now I just have some algebra to do, multiplying both sides by C and dividing both sides by cos 40. There's two steps I did there at once. C is equal to that expression there, so let me just do that on the calculator here. I'm going to go 8 divided by, on this one, 40 cos equals, is about 10.443. Okay, so now I have solved the triangle. I know all three sides and I know all three angles, 40, 50, and 90. Okay, well, let's do a couple more. What if I have something like this? There's my 90 degree. Again, let's call it A, B, and C, and I like C as my 90 degree angle. What if I know, let's see, this is 48 degrees. Doesn't really look like 48. And this is 17. How do I find A and B and this other angle, capital B? Well, capital B we can figure out pretty quickly in the same way as before. I'm actually going to do it this way. B plus 48 is 90 because I know that there's 90 used up in my triangle. These two have to add up to 90. So that means that angle B must be equal to 42 degrees. Okay, and now I still need to find out little a and little b. Well, okay, I want to use my 17 and one of these angles together. So let's say I go from A, I'm going to use 48 degrees, some ratio with the opposite side and the hypotenuse. That's sine. Sine of 48 degrees is equal to the opposite to a, little a, divided by the hypotenuse, which is 17. So 17 sine, that's multiplied, 17 times sine 48 equals a. And that means, let's just finish this off again, 17 times 48, press the sine key, press equals, a is 12.633 approximately. Okay, so we've been able to solve things in a couple of different ways. That gave me A. I'm not quite finished yet. I got to do B, right? Well, let's see. I can use 42. I can use 48. Let's do. We'll use the 48 this time. So again, I want to use the adjacent side to A with the hypotenuse, not with my new, not so accurate value of A here. So once again, I'm using this angle. I want to use the adjacent side and the hypotenuse. Sounds like cosine to me. Cos 48 is the adjacent side, B, divided by the hypotenuse, C, which is 17, or that's 17 cos 48 equals B. So depending on your calculator, you might have to press the cos button and then type in 48. So another way to do this, I could calculate cos 48 and then multiply by 17. I'm going to do that this time. So 48 cos and then times 17. That'll work out the same way. 11.375 approximately. Okay, and so now I have all three sides and all three angles, and we've solved that triangle. Okay, I think we're going to continue with the inverse trig ratios in the next video. Thanks.